Hi, I'm Goswat, 12 years old, Primary 6 from Yiming Primary School. For this lesson, we are still at ordinary differential equations. In ordinary differential equations, we'll learn more than 80 methods. Right now, we have only learned some of them. And in each of these methods, we need to keep on revising. Other than keep on revising, we also need to learn how to use these methods, the different usage of these methods, and different combinations of these methods. Okay, so to learn all those, we'll learn them by exemplification. That means we'll have lots of examples. Okay, for example, this example that we have over here. So let me just tell you, for different examples, we need to know, well, are these answers correct? Are there other answers? Or are these answers not so perfect? Okay. So this example in this lesson is y prime prime, which is the second derivative of y, minus 2y, the first derivative, plus 1. And I mean, this is y plus y, and this is equals to 0. So this question is like this. Firstly, let's check what type of methods can we use for this. Well, there's one of the methods that we have learned called the characteristic equation. The characteristic equation, let's try to use it here. So let's let something. But I've already checked that this is a homogeneous differential equation. So if you're having another example, you must check, is it a homogeneous differential equation? For characteristic equation, you can only use it if it is a homogeneous differential equation. In this case, it is. So that means you can use this method. So for this time, I'll let y to be e to the power of, I'll call this lambda. So lambda x. This lambda, okay, let's just say it's just a constant. So second derivative, that means you have to differentiate this 2 times and you'll get a lambda squared outside. But this part, no matter how many times you differentiate this, it's still there. So we just cancel that out. Now it becomes like this. I want to first find what is lambda. So for that, we can factorize. So that means, okay, although these have 2 roots, but they are both 1. These are both 1. So how should we write it if it is y? Why? Well, the first part is the most obvious part. Simply like this. But how about the second part? Would it be the same? But let me just tell you, it is actually like this. But why does it have to be like this? So in this lesson, I'll show you why it doesn't have to be like this. Now, the simplest and the worst reason is just that you say, this is a second derivative. Second derivative, 2 constants, that's why. But no, I'm going to show you other different ways to tell you that this is correct. So, let me just tell you, in this differential equation, we have one theory which, as it says, if you find that answer, it's a unique answer. So, well, that will apply for this part. So, that theorem will actually be the second reason. But I'm going to tell you one more reason. Well, that reason includes us verifying. So, if you say, this is times 1, which is x to the power of 0. Here's an x. Now, what if we go up to x squared? Because if you just add another constant, well, no, that will combine. So what if we try with an x squared? So that means y would become like this. Now, how do we verify? We have to put this back. So when we put this back, that means we have to find the first derivative and the second derivative. First derivative, well, that's very simple. This part still stays the same. This part, be careful. You have to use the product rule. First, with respect to x. But wait, okay. So you can first put it like this. Then this is the second term, which it becomes like this. How about the third term? Third term, you have the product rule. Yeah, you also have to use it. So let's try first with respect to this x squared. Then after that is with respect to e to the power of x. Now we realize each of them have this e to the power of x. So can we just factorize it so that the next step it will be simpler? Well, yes, we can. So first become like this. These two, both of them have x. So let's factorize that x. How about all these constants? Now you might think, these constants, constants, it's just a constant. How about we combining them? But wait, let me just tell you, what is our main reason here? We need to say that from this part, we still need to show that it is this answer. And at last, we need to cancel out a lot of things. If you want to cancel it out, and you first change this into another constant, then you get confused in all these constants. Which constant is, what constant plus what constant, all those. So no, we'll just leave it like this, so that at last when we simplify, it's simple. So this part is the first derivative. Therefore, the second derivative. But beware, in the second derivative, each of these terms also have this e to the power of x. So let's just leave that e to the power of x at the end first. First part, product rule in this part. So these two constants become 0. This part, x, differentiate, just left this. How about this? Well, this part, yeah, it's still simple. Then after that, what happens? This first part is with respect to this part. Then after that, we still have one more part, that is this e to the power of x. That means all this part just comes down. Okay, now inside here, we try to simplify a little bit. What happens? With the first constant, C1, only this part. How about C2? C2, you realize here you have another part, so you can combine those. This is C2. C3. Here you have one part that don't have others. This C2 have an X, but there's no other C2 with an X. How about this 2C3X? Here, you have one more part, so combine them. And the last part is just stay the same. Right, now, we have to start this back here. So, we put all these inside. So this part, it means it's here. But you also have to be aware that each of these also have e to the power of x. Then after that, minus 2 of these. So you have to have 2 of these. Okay. So at this point, you have to be really careful not to write the wrong numbers. Otherwise, it will be very hard for you to find out where it went wrong. Then after that is this part. You have to add back. Okay, like this. Let's try to find things to cancel. C1, so you have a minus 2, but then you plus 1. So you don't have a C1. Let's mark those out first. C2, this part and this part cancel. How about 2C3? Are there any parts to cancel? Okay, so it doesn't seem like to have any parts to cancel. Okay, so we'll leave this there. How about this C2x? Are there any other parts? So C2x, here you have minus 2 of these, but you have the plus 1 back. So, okay, this part. These parts cancel out. How about this? 4 and 4. Okay, they also cancel out. These 3 parts, okay, also cancel out. So what you're left with is this. And what is this equal to? It's equal to 0. To make this 0, the only way is that the third constant is also a 0. That's the only way to satisfy this. Since at last, all these you have to satisfy, otherwise you're having a totally different thing. So that means this part is 0, then it's just the same as this part. Well, if you want to try with other constants, well, let me just tell you, you can go on your own. So that means for this part, it's just 0. But let's try. Is this really right? So this is testing for 3 of these constants. But what if there's just 2? That means just like this. So, do you want to try that out? Well, I can try it if you want. But let me just tell you, it's actually just the same. Except that you just have to cancel out all these C3s. Okay, so that means this lesson, I think I can end here. So you have to be really, really careful of these questions. And although it's just this short, but you have to be careful. You have to ask yourself questions. Is this answer correct? Is this answer? How about other answers? How about if I include other things? For example, I include this x squared. Is it going to change this question? But at last I found no. It's just going to be a 0. So that part is totally useless. So those 3 reasons for this being like this. Okay, the first, second derivative, so you have 2 constants. The second is that there's a theory that says about these unique answers. And the third part is this verification. Okay, so for this lesson, I think I can end it here. So we'll see you in the next lesson, and if you like our videos, don't forget to subscribe to our channel, and thank you for your watching.